Question 403. A person is standing 2,100 feet away from a rocket's launching point. The rocket is fired vertically upward at a rate of 300 feet per second. After 21 seconds after liftoff, the question is, at what rate is the distance between the person and the rocket changing? Alright, let's draw a picture that explains this situation. So here, let's say this is a person, and this is a rocket's launching point. The rocket is fired vertically upward, right? So it's going up like this. Here is a rocket, and the person is 2,100 feet away from rocket's launching point, right? As you see it, this distance is changing as the rocket goes upward, right? So I'm gonna write variable y here, and as the rocket moves up, the distance changes, right? It changes. So this must be variable. Let's say the distance d. So far so good? Okay, the question is, at what rate is the distance between the person and the rocket changing? So we have to find d over dt. That's the question, right? Okay, so far so good? So we must write the equation that includes the variable d, right, and y, right? We're going to use this rate right here. Okay, so let's write the equation using the Pythagorean theorem. 2100 squared plus y squared is equal to d squared, right? Let's differentiate this equation with respect to time t. Okay, derivative of constant is always equal to 0, right? So I'm not going to write it. Derivative of y squared, power rule first, 2y times derivative of y itself with respect to time t. So dy over dt is equal to power rule to the chain rule dd over dt, right? So cancel this out. Okay, what is dy over dt? The rocket is fired vertical upwards at a rate of 300 feet per second, right? That's the rate. So it is given that dy over dt is equal to 300, right? And we are looking for this value after 21 seconds after liftoff, right? So what is the value of y after 21 seconds after liftoff? The rate is 300 feet per second, right? So the value of y at this point is equal to 300 times 21. Does that make sense? Okay. Also at this point, we're going to have to find d, the distance d, right? 2100 is equal to, this number is equal to 700. Okay, let's use the 300 since we have a 300 here. 300 times 7, right? Okay, here we have 7, right? So we're gonna rewrite this 21 as 7 times 3. Okay, so both of these numbers right here has factor 307. Here we have a 3, right? Here we have 1. So use these two numbers to find the distance d. Okay, so using the Pythagorean theorem, if this is 1 and if this is a 3, what is this? Square root of 10, right? So this is going to be square root of 10, and this must have a factor 307. So 300 times 7 times square root of 10. Does that make sense? So that's 2100 square root of 10. Okay, now let's substitute these values in this equation right here. Okay, so y is 300 times 7 times 3. dy dt, that's 300, right? 300 is equal to d, that's 300 times 7 times square root of 10 times dd over dt. So far so good. So let's simplify this. Cancel, right? So we have 900 here over square root of 10. That is equal to dd over dt, right? And if we rationalize this, we're going to multiply square root of 10 here, square root of 10 here. So we have 900 square root of 10 over 10. So that's going to be equal to 90 square root of 10, right? So the distance is changing at 90 square root of 10 feet per second. Okay. Question 404. At what rate is the angle of elevation between the ground and the person's line of sight changing? Okay, the angle of elevation between the ground and the person's line of sight is this. So we're going to write angle theta here. And it was also given the rocket is fired at a rate of 300 feet per second, right? So dy over dt is equal to 300. And after 21 seconds of liftoff, y was 300 times 21. And we also found the distance d. The distance from the person to the rocket was equal to 300 times 7 times the square root of 10. We found this from the question 403, right? So far so good. Okay, now we're gonna have to write the equation that includes the theta, right? So we're gonna use these two legs since rate of this was given and this is constant, right? So we're gonna use tangent. So tangent theta is equal to opposite over adjacent, y over 2100, right? So let's differentiate this with respect to time t. Okay, so derivative of tangent is a secant square. So secant square theta times derivative of theta with respect to time t. That's a d theta over dt. Chain rule, right? Okay, remember this expression is 1 over 2100 times y, right? Constant times y. So derivative of that expression is equal to 1 over 2100 times derivative of y, which is equal to dy over dt. So far so good? Okay, we're gonna have to find secant theta, right? The value of secant theta is, it's actually 1 over cosine, right? Cosine is adjacent over hypotenuse. Secant is then hypotenuse over adjacent, right? So hypotenuse, that's going to be 300 times 7 root 10 over adjacent 2100. Okay, square. Now we have the theta dt is equal to 1 over 2100 times dy over dt. dy over dt is 300, right? So let's simplify this. Here we have 2100, right? 300 times 7, 2100. So we have 10 here. I'm gonna write right over here. Square root of 10 squared, that's 10. d theta over dt is equal to, here, 300, 2100, that's just 1 over 7, right? It's equal to 1 over 7. So d theta over dt is equal to 1 over 70. So 1 over 70 radians per second, right? Question 411. A 6-foot person walks directly towards a 30-foot tall street lamp. If the length of a person's shadow decreases at a rate of 3 feet per second, at what rate is the person walking? Okay, let's draw a picture for this problem. We have a lamp, right? So this is our 30-foot lamp. And let's say the person is standing right here. Okay, so we'll have shadow right here, right? Okay, I'm gonna let this shadow be x, okay? And let the distance between the lamp and the person be y. Okay, so this is 30 foot. The person is a 6, right? So here's a 6. Okay, it is given that the length of a person's shadow decreases at a rate of 3 feet per second, right? So we have dx over dt. Change in shadow with respect to time t, that's -3, right? And the question is, at what rate? What rate is the person walking, right? Let's say the person is walking at a rate of 2 feet per second. This person is walking this way at a rate of 2 feet per second. That means the distance from the lamp to person is decreasing at 2 feet per second, right? So this question right here, at what rate is the person walking, is asking us to find the change in distance between the lamp and the person with respect to time, right? That's the question. Okay, so when you look at this figure right here, we have 2 different triangles. Here a small triangle, here a big triangle, right? And do you guys see that they are similar to each other? Because they sharing this angle right here, and here we have a right angle, right? Right angle. So since angle from this small triangle, the angle from this big triangle, and right angle from this small triangle, right angle from this big triangle, we have 2 congruent angles, right? So by AA similarity, these 2 triangles are similar. So we can write the proportion, right? Okay, the height of this big triangle, which is 30, over height of this small triangle, 30 over 6 is equal to base of this big triangle, which is y plus x. Y plus x over base of this small triangle, which is x, right? They're equal to each other, right? So 30 over 6 is equal to, if we simplify this, that's just the 5, right? So cross multiplication, 5x is equal to y plus x. So we have a 4x is equal to just y, right? Now we're going to differentiate this equation with respect to time t. So we'll have 4 times derivative of x, that's a dx over dt, is equal to derivative of y, dy over dt, right? It was given that dx over dt was -3, right? So this is a -3. So what is dy over dt? our dy over dt is equal to -12. The unit is feet per second, right? So the distance from the lamp to the person is decreasing at a rate of 12 feet per second, or we can say that the person is walking at a rate of 12 feet per second, right? Question 420. There is a point moving on the graph of y is equal to x squared minus 4. How fast is the distance between the origin and a point changing when x is increasing at a rate of 2 units per second at x equal 1? Okay, let's draw the function y is equal to x squared minus 4. So here's the x-axis. Here is y-axis. Okay. This is quadratic, right? And with the y-intercept -4. Let's say here's -4. And x-intercept will be plus minus 2. Right? So we have a parabola that passes through these intercepts like that. So far so good? Okay. The question is, how fast is the distance between the origin? Here is the origin. And a point changing when x is increasing at here. X is increasing at a rate of 2 feet per second, right? So it is given that dx over dt is equal to, right? At x equal 1. At x equal 1, the point is right here. So we're going to let this be x comma y. Okay? The distance from origin to this point is right here. So let's say this is distance d. Okay? The question is asking us to find dd over dt at x equal 1, right? So look at this distance from the origin to the point. That's distance, right? X is increasing. X is increasing at a rate of 2 feet per second. So x is increasing this way, right? Then distance, it looks like it decreases, right? So we have to find how fast is the distance is decreasing at x equal 1. So let's start with the equation of the distance. The distance between 2 points. Let's use distance formula right here. Distance is square root of x2 minus x1. Remember, the origin is 0, 0, right? So x minus 0 square plus y2 minus y1 square. So y minus 0 square, right? So that's going to be equal to square root of x squared plus y squared, right? We're going to differentiate this equation, but we don't like square root, right? So square both sides first, like that, and then differentiate this equation with respect to time t. So far so good? Okay, so right here, derivative of d squared power rho times chain rho dt over dt, right, is equal to power rho 2x times dx over dt chain rho plus power rho chain rho, right? So eliminate 2, right? Okay, when x is equal to 1, what is, when x is equal to 1, what is value of y? Here, y is x squared minus 4, right? So when x is equal to 1, 1 squared minus 4, y must be -3, right? So y is -3 here, right? Okay, dx over dt is given that this is 2, right? This value is 2. Then what is dy over dt? It is not given, right? So we have to find dy over dt from this equation right here. Okay, let's erase this. So let's write y is equal to x squared minus 4. Okay, we're going to differentiate this equation to find the derivative of y with respect to time t. So differentiate with respect to time t. So dy over dt is equal to power of 2 times x times dx dt, right? dx dt is 2. It is given that this value is equal to x is equal to 1, right? So this value is equal to 1. So dy over dt is 2 times 1 times 2. This is going to be 4, right? So we're going to substitute 4 here. All right? Okay, what is our d when x is equal to 1, y is equal to negative 3? Here, we're going to use this equation right here to find d. So when x is equal to 1, right, and y is equal to negative 3, then our d is equal to square root 1 squared plus negative 3 squared. That's the square root of 10, right? So this value is the square root of 10, right? Okay, now let's simplify this. Square root of 10 dt is equal to 1 times 2, that's 2, plus negative 3 times 4, that's minus 12. So that's negative 10, right? So dt is equal to negative 10 over square root of 10, right? Let's rationalize this, right? So we're almost done here. That's negative 10 square root of 10 over 10, right? So cancel these numbers out. So the answer is equal to negative square root of 10. So at this point right here, as x increases at a rate of 2 feet per second, the distance is decreasing. The distance from the origin to the point on the curve is decreasing at a rate of a square root of 10 units per second, right? Question 421. The two legs and the hypotenuse of the right triangle above each increase with time. The area of the triangle is increasing at a rate of 4 times as fast as the leg A is increasing, and it is given that dv over dt is 1/2. When A is equal to 12 and B is equal to 5, what is the value of dA over dt? Alright, actually the right triangle is given right over here, right? And it says the area of the triangle is increasing at a rate of 4 times as fast as the leg A is increasing, right? So we can write change in area with respect to time t is equal to 4 times change in leg with respect to time t, right? Okay, now we're going to have to write the equation, and that equation should be the area of the triangle, right? So area of the triangle is 1/2 times base times the height. And we're going to differentiate this equation with respect to time t. So far so good? Okay. dA over dt is equal to 1/2 times the derivative of AB, right? So we're going to have to apply the product rule. Derivative of leg A, that's dA over dt times leg B plus leg A times the derivative of leg B, that's dB over dt, right? Okay, it is given that dB over dt is 1/2, and we are trying to find dA over dt when A is 12 and B is equal to 5, right? So we're gonna substitute these numbers. dV over dt, that's 1/2, and A is 12, B is equal to 5, and dA over dt, this is 4 times dA over dt, right? So 4 times dA over dt, right? So that is equal to 1/2 times 5 dA over dt plus 12 times 1/2, that's 6, right? Now we're going to multiply by 2 each side. A times dA over dt is equal to, we have a 5 dA over dt plus 6. So 8 dA over dt minus 5 dA over dt, that's going to be equal to 3 dA over dt, which is equal to 6, right? So change in leg A with respect to time t is equal to 6 divided by 3, 2, right? So the answer has to be 2.